Hey guys, welcome back. So this will be the first time we're going to run our simulation in Galapagos. And after that, we're going to see how we can improve the result even more by tweaking our definition, looking mainly at our view rays, how we can reward certain behavior and penalize other behavior we don't want to see. We're going to continue with the previous definition, and I adjusted it a little bit. I moved the three panels with our fitness values a little bit to the right, and I grouped them, and I also made a small group for visualization purposes with our four buildings, our view rays, our surrounding 3D context, and our plot outlines, just to visualize quickly in Rhino the elements. So let's start by running the simulation. Before we do that, we need to quickly adjust a few things. First, we're going to increase the footprint area a little bit, because now we have it set exactly at 1000, but we're going to increase it to 1100. The reason is that almost always our footprints are going to be cut off by the plot outlines, so we always will result in a lower value. And by increasing this value, we counteract this from happening. So it will be more easy for Galapagos to find 1000 as the optimum. And the second thing we're going to do is to look at our accuracy from our view rays, which was this number. Let me also change the description. Because now we have a grid of 5 by 5, and if I zoom in Rhino a little bit, you can see the grid being represented by the view rays. But we can lower this number, and the lower this number is, let's say if I set it to 3, you see that our view rays increase. So now we have way more view rays, so the accuracy of the simulation will be bigger. The only thing is that it will slow down the simulation significantly. So you need to find a way between accuracy and the speed of your simulation, like what you value more. You can even set it to more, let's say you can set it even to 8, which has way less view rays. So it's up to you. The only thing is, like, every time you adjust this number, like we saw in the previous lesson, you need to also adjust the bounds, and that's what the rangefinder is for. So you always need to keep in mind to hit the reset button every time you start a simulation, before you start the simulation. So let's keep it at 5, I think that's fine. So hit the reset button, and let's open up Galapagos by double-clicking the Galapagos component. So we're going to optimize not the maximum, but we're going to optimize for 0. And we're going to increase the initial boost a little bit to 5. So we have a wider net in the beginning a little bit. And we're also going to change the inbreeding instead of 75 to -75. So there will be more zoophilic relationships being formed instead of the incestuous ones. Because it's very hard to predict which combinations of genes are working and which not. So if that's set, you can go to solvers and hit the start solver button. Now in the Rhino canvas, you see slowly the different variations being projected. And you can set it to the slowest one here, hitting this button, to see all the different combinations being represented. And if you want to speed it up, which we're going to do, is simply hit the fast button. And you can minimize Rhino to make the simulation run even more faster. So this is the time for you to make some tea, make some coffee, go for a walk, because this is going to take some time. Usually I let it run for around half an hour, 40 minutes, depending on how many iterations it has. And of course, the faster your laptop or your computer is, the more faster the simulation will run. But it depends a little bit upon you how long you want to wait. So right now, in the 73rd iteration, we've reached a point where the lowest genome or the worst genome and the best one are more or less equal. They're around 0.5. So it's time to, if you want to, you can kill the simulation. And that's what we're going to do right now, just to see the result. So we can do that by hitting the Stop Solver button. Select the best genome and hit Reinstate and hit OK. So let's go to Rhino and let's see the result. Let's go to Top View. So let's also check our panels to see what's up. So let's start with the shortest distance, and as you can see, all the values are above 15, so that's perfect. Let's check the areas of the footprints, and as you can see, they're also within our tolerance, well, almost. The first one and the last one, they're just outside the 50 meters tolerance, but the middle two, the 996, those are perfect. Those are exactly within the tolerance, so that's great. And the view quality, those are a little bit harder to determine because we don't really know the maximum value they could have, but you can check that in Rhino. And as you can see, the building on the left top, it rotated in a certain way that it avoided the curved building, so that's great. And I think as a reaction to that, the building to the right also rotated a little bit. And the other two, they're also fine. They rotated in a way that they had the most best views, I guess. But there's room for improvement. Like these views in between, they still are pretty close and they still are pretty blocked by the other buildings. And that's exactly what we're going to take a look at in the next lesson, but also a little bit in this lesson. So those are the things we're going to start right now, to tweaking our definition a little bit so we get a more better result, especially the view part. So the first thing we're going to do is a small thing, and that is inserting a collapse polyline component in between the output of our region intersect and our for footprints curve component. So let me insert a component. It's called polyline collapse. If a line segment is smaller than a certain amount, which is the small letter t, it will collapse that part. And this will create a more clean outline. Because if I go to Rhino, I don't know if it's the case, but as you can see here, this line part is very tiny. Let me measure it so we know more or less what it is. It's only 2.7 meters, which is kind of small. So we could say like, well, we want to collapse that line piece, for instance. So let's connect it and let's set a distance of 5 meters. Or let's say 4.5. And you need to take into account that also the accuracy of your grid, if your grid accuracy is 5, you may want to choose a value that's a little bit smaller. So at least they have some views to be projected on that line curve, let's say. If you go back to Rhino, you see that this line was collapsed. So that's nice. And I think also here, yeah, this line piece was also smaller than 4.5, so it also got collapsed. So that's nice. So that's one thing. So we get our outlines are a little bit more clean. The next thing I want to do is to start looking at our views, like I explained before. That's mainly the part we're going to try to make better. So there are two parts. We're going to first penalize views that are smaller than a certain amount. More or less the same as we did when a building comes closer than 15 meters. We were going to penalize it. We're going to do the same with our views. And we're going to do that here, where we get the view length. So let's insert a slider, and that's going to be the slider. We're going to say, well, if a view is smaller than this amount, we're going to penalize it. So let's set it to 100 meters. I think that's fine. So let's say if a view is smaller than, I don't know, 40 meters, we want to start penalizing it. So first we need to separate our views, and we can use a larger than component to do this. Just like that. And the next component will be a dispatch component. Now let's graph the input just in case, so all of them have their own branch, because later on we're going to add them back together, so we don't mess up the tree structure. Yeah, so the A, those are the few lines that are larger than 40, so we want to leave those alone. But the ones that are smaller, we're going to remap these numbers. So we need a remap component, remap numbers component. So the source domain lies between 0 and 40. So that one goes in the S, the source domain. So we need another construct domain component, so let's copy this one over. And the way we want to remap it is basically, instead of going from 0 to 40, we want it to go from 40 to 0. And I'm going to explain that to you in a while, why we're going to do that. So let me insert a panel. And let me, instead of using the values, I'm going to use a slider so I can explain it to you a little bit better. And of course, we need to change this one into 0. Like that. So it's from 0 to 40 and then 40 to 0. Because let's say if a value is 40, that's still okay. But let's say if a value drops below 40, we want this value, the remapped value, to increase. Because if this value nears the 0, then we're going to get 40 out of it. What we're going to do now is we're going to square this value to make it even more extreme. So instead of 40, we're going to get the square root, which is 1600, which is a lot. And then we're going to get the negative of this number. Because as you can imagine, we don't want a big number, because then it would mean that if a value is below 40, it would actually be rewarded. That's why we use the negative value for that. So now if a value is 0, it's really bad. It means that the two buildings are sticking to each other. Our view race gets a negative number to be added to the total, which will decrease the total amount, which would be bad, basically. But if this number increases, you see that slowly it's going to get to 0 again, because if I reach 40, you see that now I'm at 0. If it's above 40, like all these values, they don't matter anymore, because then the A takes over. So now we can use a merge component to merge the two streams back again. So that's the A, the B goes in here, like this. Great. So the only thing you need to do is to add them all together again. So let me move the PathMapper component to the end. So let me connect this one to this one. We simplify this output. And now connect this one to this one. It's one extra branch, so let's adjust the PathMapper. Let me reorder this a little bit. So let me show the whole total again with a slider, because I think it's the most easy. Let me put a panel like that. And let me connect a slider to here instead of the length, so I can manually show you what's going to happen. Okay, below 40 you want to penalize, and above 40 that's fine. So you see that above 40 I just have the number, like the actual number of the view length. But as soon as I drop below 40, you see that I get a negative value to start off with, but that value increases exponentially. All the way to 0, which would be the worst outcome, and we get minus 1600. So that's one way to penalize the views. I think there are various ways to do this, but I think this one is pretty effective. Of course, you could argue that the square component is a little bit too hectic. You could also directly connect the remap numbers to the negative component to avoid that. Depending on how extreme you want to penalize the views that drop below the range or the amount we set. But it's all up to you. It's a little bit of tweaking and finding out and playing with the sliders to get the most optimal result. So in the next lesson, we'll take a look how to positively reward a view if it looks at a certain landmark. Now we just focus on the negative, but the next lesson we'll directly jump into positively rewarding a view. Thank you for watching, and I'll see you in the next lesson.